Hello, let's continue our Sudoku adventure with Leaky Teapot by Tony Zampini. Now, yes, you aren't seeing double. I did publish this one yesterday, but I made an extremely lucky mistake. A lucky mistake is when I make a logical error that happens to have gotten me to the correct answer, but I made it so early in the puzzle that it completely invalidates the solve, and the puzzle was much more difficult than my solve path showed. So I am redoing the puzzle. I remember some things about it, but honestly, because my mistake was so early, it'll be like solving it for the first time. So anyway, let's go over the rules. We do have normal 6x6 Sudoku rules, which means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have this modular line in the grid. The way this line works is you take any 3 adjacent digits on the line, like these 3, these 3, these 3, and they need to each have a distinct remainder when dividing by 3. So basically we have 3 groups. We have the 1-4 group, the 2-5 group, and the 3-6 group. 1 and 4, when you divide them by 3, they both have remainder 1, 2 and 5 have remainder 2, 3 and 6 have remainder 0. And we just need to have one of each from this group within these 3. So it doesn't have to be in this order. So we could do like 1, 2, 3. That would be fine. We could do 1, 2, 6. We could do 4, 2, 6. But we could also swap these. I could do like 2, 4, 6. I could do 2, 6, 4, right? The order doesn't matter, just as long as we have one of each. But then keep in mind that all groups of 3 on the line, including these overlapping ones, do need to have one of each as well. All right, and then we have crop key. So white dots and black dots. White dots tell us that those 2 digits are consecutive. So if this was a 2, this could be 1 or 3. And then black dots tell us that the 2 digits have a 1 to 2 ratio, meaning 1 is exactly double the other. So if this was 2, this could be 1, because 2 is double 1. Or this could be 4, because 4 is double 2. Now, not all dots are given. That means if we put, say, 2, 4 over here, there could have been a black dot. We could have given a black dot there. We didn't. That's perfectly fine. So this black dot isn't telling you about everywhere that we have 1 to 2 ratios. Just these 2 cells have 1 to 2 ratio. That's all it's telling you. That's it. All right. And that is it for the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so we are going to color, so green, purple, orange. Now, what do these colors mean? Well, each color is representing a group. We don't know which group is which, but let's say this ended up a 4. Then that would mean that wherever in the puzzle we use green, that's the 1-4 group. But this digit could also end up maybe a 2, in which case that means everywhere in the puzzle that's green, that's the 2-5 group. The only thing we do know is that purple is a different group than green, and orange is the 3rd one. So we have 1 of each group because that's what the modular line tells us. So these are the only 3 groups that exist. We don't have more colors, just green, purple, and orange. So when we get to this cell here, what color do we put here? Well, if we look at this overlap, we already have a purple and an orange in this set of 3. So the only color we can make this is green. And that's going to, the same logic is going to cause this to cycle. So we're always going to go green, purple, orange, green, and then we're going to have purple, orange, and then green, then green, purple, orange, green, purple, orange, green. Okay, so the first thing we see is that these 2 cells are both green across a black dot. So we want to think about this because this is going to represent an entire green group. So it could be 1-4. If it was 1-4, that does not have a 1 to 2 ratio. If it was 2-5, that doesn't either. So this has to be 3-6. So we know that all the greens are 3-6. Now this is where I made a mistake yesterday. So my solve path so far is exactly the same. But yesterday I said that this couldn't be 1-4 because it wouldn't be consecutive with 3-6. But actually it could be 1-4 because we could put a 4 here and a 3 here. So we got to be careful. So that's as far as I got before making a mistake that trivialized the puzzle because I accidentally got it right. So let's see what the next step actually should be. Maybe I can continue coloring. We know that both of these are consecutive with the same 3-6, which is interesting. So we need, but these could be the same digit as each other. I don't see why they couldn't be. We need 1 more purple and orange across here. So we have both our greens here, we have both our greens here, we have both our greens here. I wonder if we can continue with greens somehow. Let's see. I'm just trying to see if there's anything obvious we can continue with. So I may have to subcolor. So for example, I could flash this with gray. Actually, yeah. Flash this with gray and flash this with white. So maybe not white. Let's just pick something else. The problem, I need something that's, okay. Let's not use gray. Let's flash this with red and flash this with blue. That way they both appear on the top left. I just don't like using two colors where one of them's on the bottom right, one of them's on the bottom. Anyway, not important. So this is the red version of green, and this is the blue version of green. We don't know which one's 3 and which one's 6, but we know they're different. And so now we know this is the blue version of green, this is red, and then this is blue. So now we know that blue-green is a specific digit. So like this looks into here, this looks into here, this looks down. So we need a blue-green in this box somewhere, and this is the only place it can be. So we actually have a hidden single blue-green right there. And then we need a blue-green in here, and that's got to go here. We know it's not orange and purple because it's green, right? So this is our blue-green, 3, 6. And then in this box, it has to go here now. Can I do the same thing with red? Yeah, in this box, this is our red 3, 6. In this box, this is our red 3, 6. And then in this box, it's here. In this box, it's here. Okay, so they're somewhere in here. Okay, but this cannot be a green, right? A group can't be consecutive with itself. This would be a 3, 6 across a white dot. So this can't be our red 3, 6. So if it can't be here, then it must be here. And then now this is our final one. So we know exactly where all the 3, 6s are. We just don't know which one's 3 and which one's 6. Okay, so do we need to subcolor the rest of these maybe? Let's see. It might be helpful, but I don't know how to connect the purples or the oranges. So I'm not sure how to subcolor those yet. Okay, so we have a bunch of things that are consecutive. Here we go. Okay, so this cell and this cell, I don't know if this is a here we go, but let's think about it. Yeah. So this has to be 3. Let me explain why. This cell is consecutive with 3, 6, and this cell is consecutive with this red 3, 6. And they're different digits because the column, right? Column can't repeat digits. So if this was 6, the only consecutive digit with 6 is 5. So this would have to be 5, and this would have to be 5, and that would break. So actually, our red 3, 6s are 3s, and our blue 3, 6s are 6s. And I don't need the subcoloring anymore. So I think we can just get rid of that. I'll keep the color because I'm going to use the other colors maybe. Yeah, cool. So we have all the 3, 6s placed. Now this has to be 5, and we don't know what color 5 is yet. I guess we'll find out soon, hopefully. Now these are a 2, 4 pair to surround the 3, and that leaves the 1, 5 here. And this 5 tells us that's 1, that's 5. Okay. Interesting that we don't really have a relationship to these colors yet. 2, 4 could be either color. Oh, I mean, yeah, we don't know what color we're assigning to 5 and 1. But these are different, which we knew they would be. Okay, well, maybe we can do more Sudoku. 5s look up. So this is a 5. So I need a 1 in this column, which can only go there. This is 2 or 4. This is 2 or 4 for the row. I wonder if the colors are needed anymore. I'd like to keep them just for... yeah, you know what I mean. Just to keep track of the modular line. These are consecutive. So one way to think about consecutive digits, and I don't know if this is helpful in this moment, but actually maybe we pencil this first. Yeah, 2, 4, that actually helps. One way to think about consecutive digits is we're going to have 1 even and 1 odd because they're consecutive. So you can't have 2 evens, 2 odds. Those wouldn't be consecutive. So 1 even, 1 odd. This is our even. This is 2, 4. So this has to be odd, and it's not 3. So it's 1 or 5 only. So either 1, 2, or 4, 5. Don't know which one. This is interesting. Okay, maybe this black dot helps us now. So we need to be 1, 2, 4. Okay, so we know that this contains the 2, because otherwise it would be 1, 4, which is not working across a black dot. So we definitely contain the 2, which means this is not a 2, because otherwise it would remove 2 from both of these. What am I missing here? We need a 5 in this column. Yeah, again, I don't know how to distinguish these colors. There must be something going on with that. This is also 1, 2, 4. So 1's one of these 2. We know that. These are both orange. I wonder if that's... So this is either going to be 1, 4 or 2, 5. Right, so we know these both are purple, which means this is orange, which means this is orange. This is purple. This is orange. Okay, I finally got my coloring good. I don't know. Maybe I've been able to do that this whole time. Oops. Okay, well, it's fine. I'm not doing this puzzle again. Anyway, oranges. Got an orange down here. How did I miss this? Anyway, maybe it was after I got these, so I wasn't paying attention. I think it might have been. Okay, do I get more colors? Yeah, this is purple for the row. So have I colored anything that makes it obvious what are... So, I mean, this is 2 or 4, and this is 1 or 5. So they're different versions of purple, but we don't know which. This is the... Oh, yeah, this is orange, because we can't have 2, 4 both be purple. So this 2, 4 pair is telling us that this is the orange version of 2, 4, which makes this have to be purple, which makes purple... Oh, we colored a 1 orange, sorry. So oranges are 1, 4. So this is 4, this is 4, this is 1, this is 2, this is 2. That's a 1, 4 pair. This is a 2, 5 pair. Oh, yeah, 2, 5. Oh, so that means, yeah, purple is 2. This is 4. Yeah, sorry, this is orange and this is purple. Let's finish the colors. So 4 and 1, we get 5 and 2, we get 2 and 5, we get the 2 here, we get the 5 here. We get the 1 and the 4, we get the 4 and the 1, and we're done. Okay, cool. Yeah, I think I overcomplicated that at the end, but at least my logic was sound this time, I hope. Cool. Well, hopefully you enjoyed the second solve of this one. I'm going to make the old video private just because it's completely invalid, and I'm going to update the links of the spreadsheet so it points to this one. So if you're watching this later, you might be a little confused about why this is the second video, but there you go. Cool. Well, hope you enjoyed this, and if you did, then why not leave a like, subscribe, and a kind comment below.